Okay, this is problem number 4 on exam number 1, and what we have here is the power of a bus engine is transmitted using belts and pulleys with the arrangement shown here. And so we see that the engine is turning at pulley A, and we have this relationship for omega A, which is 20t plus 40 radians per second, where t is in seconds. And what we're asked to do is to determine the angular velocities of the pulleys B and C when t is equal to 6 seconds. One key point that is easy to overlook is the fact that the last sentence says the hub at D is rigidly connected to B and turns with it. So what that means is once we solve for omega D, omega B would be equivalent to omega B. So let's go ahead and get started solving this problem. So we're going to try to draw the diagram here. And so we have our first pulley here, and this is A, and it is turning at a rate of omega A, right? And we also have our smaller pulley here, which is D, which is rigidly attached to a larger pulley, which would be B. And so our first connection is between the pulley A and the pulley D, and then lastly we have the pulley C over here, and that is connected to the pulley B. So that's our last connection there. So we have A, B, D, and C. So we have the dimensions that are provided. This radius is 75 millimeters. The radius of D is much smaller. It is 25 millimeters. And the radius of B is 100 millimeters. Okay? And then lastly, the radius of C would be 50 millimeters. So since this is a pulley, what we must focus on is the fact that the velocity at point, let's call it point P here, is equivalent to the velocity at point P here on pulley D, right? And so if we write the equations for that velocity, we'll know that V of P is equal to omega A dot RA, okay? And so we actually know all of those values because we know omega A. Let's real quick, omega A is given by the relationship 20t plus 40, and that's all in radians per second. And we know that it asks for when t is equal to 3 seconds, so that would be 20 times 3 plus 40, so that's 100 radians per second. So that's what omega A is. So we can actually solve for the velocity at this point P, and that's 100 radians per second times a radius of 75 millimeters. So that's 0.075 meters. And so we get a velocity of 7.5 meters per second. And we know that velocity is equivalent to the velocity on pulley D. So we can say omega D dot RD, all right? So we don't know what omega D is, but we know what VP is and we know what the radius is. So we can say that's equal to omega D times that radius of 25 millimeters, 0.025. So since we know what VP is 7.5 meters per second, then we can solve for omega D, which is 7.5 divided by 0.025 is equal to 300 radians per second. All right, everyone still with me? All right, so we have omega D. Now here's the catch, easiest part of the whole problem. Omega B is equal to omega D. That's it. So we know that omega B is also 300 radians per second. And we know that because the problem tells us that these two are rigidly attached. Right? If we go back to the problem, we see that it says the hub at D is rigidly connected to B and turns with it. So we know that those two are equivalent. Okay? So that's our first thing they asked us for. They asked us for omega B, so we have that now. And so the next step is to find omega C for this pulley C. And we can do the same thing as what we did for that point P. So we can select another point. Let's call it here P prime, because it is a point, and since it's on a pulley, we know that since the pulley the length of it doesn't change, that the tangential velocity has to be equivalent between those 2 points. So if we do the same process, we say V of P prime is equal to, let me slide up so you guys can see me here. All right, so V of P prime is equal to omega B dot RB. And let's go ahead and move forward and say that that's equivalent to omega C times RC. So those are the two relationships for those 2 points. And the good thing is we actually know what omega B is, we know what RB is, we know what RC, and this is what we're trying to solve for, the omega C. Okay? And so without even knowing what this velocity VP prime is, we can actually solve for omega C. So we can do that algebraically by saying that omega C would be equal to omega B dot RB divided by RC. And so if you run the numbers on that, you know that this is 300 radians per second times 100 millimeters, so 0.1 meters, divided by 0.05, and that's equal to 600 radians per second. So what we see is that omega B is equal to 300 radians per second, and omega C is equal to 600 radians per second. Alrighty.